Hello everyone. Let us now discuss how can we solve this problem, right? So minimum 1 bit operations to make integers 0. So I know the description is not clear. Let me make this description clear for you. So we are given with an integer n. So we are given with an integer n. We need to make this integer n as 0. Now we need to have only two operations. We are allowed to make only two operations. Let me tell you. The first operation is change change the rightmost rightmost bit. Right? I'll tell you what does it mean, and also change the bit left to the uh, last set bit. Let me tell you what does this mean. First thing, change the rightmost bit. Let us take an integer n is equal to 9. It can be represented as 1 0 0 1. Now we can change this one, nothing but this is our rightmost bit. So that's why I am changing it to 0, just flipping it. Right now, let us change the bit left to the last set bit. Now let us take 1010, nothing but n is equal to 10. Now last set bit is this one. Now after this there are no set bits, there are no ones after this. So left to this is 0. Either it might be 0 or 1, I don't care. But change the bit left to the last set bit will be this one, and I will just change it to 1, right? So no matter what it will be, 1 or 0, we will change it. I think you are clear, and from these two operations we can make any number of these operations, and we need to return minimum operations required for this. I think it's clear for you. Let us take an example first. Let me take 1000, nothing but n is equal to 8 here. Now what I'll do, I'll just change this 0 to 1. So 1001. Now you might say that here this is my last set bit, left to that is 0. So let us do that. 1010. I'm just flipping the bit. Now after that I will just sorry I'll just change the last set bit, right? Last bit, rightmost bit, operation 1. I'll just change it to 0. 1010. Now after that I will just change. This is the last set bit, right? Left to that is 0. I'll just change it to 1. 1110. And then I'll just change this 0 to 1. So I got it. Now after that I'll just change this 1 to 0. So 1101. Now after that I'll change this rightmost bit. So 1100. Then this is the set bit, the last set bit. Now left to that is 1, and I have just changed it to 0. Now if you see, how many operations did it take? 8 number of operations. If you doubt, just check 1, 2, 3, 4, 5, 6, 7, and then 8, right? So I just got 8 operations. Now 0, 1, 2, and then 3. 8 operations. But it is not done yet. We need to change this to 0. So to change this 1 to 0, I took 8. Now I need to make this 1 as 0 too. So what I'll do, I'll just change the last 0 to 1. I got it. Now after that I'll just change, this is the left to the last set bit. So in that I'll just change it to 1. Then the last bit will be changed to 0. So here it is. And then for this one, the left is 1. So what I'll do, I'll just change it to 0, and I got 1 0. Now how many does it took? It took 4 operations. Now let us go to this one. Now I'll just change this to the 1, and then to the left is 1. To the rightmost set bit, the left is 1. So I'll just change it to 0. Now, this 1 has made 0 by 2 operations. Now, how many operations does this 1 take? Only one operation. Now, if you see, it is it is saying something like 8 plus 4 plus 2 plus 1. Nothing but 2 power k, excuse me, 2 power k plus 2 power k minus 1 plus 2 power k minus 2, and so on till we get 1. This can be represented as 2 power k plus 1 minus 1. This is the whole thing, right? So I know that if I got something like 1000 or 1 zeros and then all zeros, right? If there is only one set bit, I will definitely execute this. But let us let us go here and check how can I make this 1 as 0, right? That's where the problem comes. There are no number of ones are more than 1, right? So here I got two ones. Now to make this 1 as 0 I need 8 operations. But to make this 1010 as 0, let us see how many operations does it take. So by removing these three, it will take only these and then all of this. So what am I removing? Let me tell you. Here, for this, I will add 2 power k plus 1 minus 1. Now, for this one, how much does it take? Now, you might ask me, right? So, to make this as 0, it will take 3 operations, right? The same to make it as 1 will be the same to make it as 0. So we'll just subtract it. Now, what number should we subtract it, right? So if I just give indices for this 0, 1, 2, 3 here if you see, I'll get it as 2 power 3 plus 1 minus 1, nothing but 2 power 4 minus 1 is nothing but 15. If you doubt, just check. 8 plus 4 plus 2 plus 1, 10 plus 5 is 15. Now from this I am just removing 3. But how do I know that it is 3? Where is this 1 present at? At index 1. Do the same thing. 2 power k plus 1 minus 1. 2 power 1 plus 1 minus 1. 2 power 2 minus 1 is nothing but 3. So 15 minus 3 is nothing but 12 operations. We just started from here instead of here. That's why it's just taking 12 operations, right? So now comes the question, what instead of this we got the next element, next number, 1110. Here comes the actual doubt and also the question, how do you handle that? 1110. So one for this one we will add, and for this one, to make it as subtracted, we will just subtract it, right? To make it as 0, we will just subtract it. Now look at this one. I need to make it as 0, right? So for that, what we will do is just add how much does it take for this 1 and 0 to make it as 0, right? So once we add, then subtract, once add, then subtract, add, and then subtract, add, and then subtract. So what will be the algorithm for this? I think you are clear for now, right? So imagine if you are given with another thing like 1, 1, 1, 1. So what we will do is add for this one, subtract for this one, add for this one, subtract for this one. The same 2 power k plus 1 minus 1 will be added and subtracted. But the k value will be changed. For this, it will be 0 here, it will be 1, and then it will be 2, and then it will be 3. Now you might ask me why? Because the 1 here will be added. It is like we need to start from the beginning and make it as 0. But as we make it as 0, the next one, after this, the next one is nothing but it need to be going back to 0, right? It should not be made as counted as these number of 4s, right? So that's how we make it. And if you have any doubts, please let me know in the comment section. And to solve this problem, we will be using algorithm which doesn't contain any dp or something like that. So we will make a string representing bits. Now in this, go with go with plus and minus by using by using bool add is equal to true first. So we need to add that first, right? So here we will get the uh, index 3 with length is equal to s dot size, right? So the index we will take, and 2 power index plus 1 minus 1, it might be added or subtracted. So if add is true, then add it. Then we need to, if add is true, so if add is true, then answer plus is equal to 2 power index plus 1 minus 1. Now else answer minus is equal to 2 power index plus 1 minus 1. Okay, so that's how the algorithm will be, and we'll be returning the answer at the end. If you have any doubts, please let me know in the comment section. If you like this video, please do share to your friends and subscribe to my channel. Thank you. Here is the code, and I have also given the code link in the description, right? So go and check it. Thanks for watching this video.